Hi, my name is Wayne Utz. I'm an electrical engineer here at ACT York Division. What we do here is a lot of ECUs, environmental control units, for military applications. And this is part 2 of the MODbus and how you might use it. The way we use it in a lot of our products is we design ECUs, the environmental control units. They sit outside. MODbus cabling, Ethernet, goes through shelter filters inside. Other people do that equipment, our end customers. And one of the things we do is each ECU has a PLC that uses MODbus to communicate between themselves. We also communicate to temperature and humidity transducers, typically using MODbus. We also use MODbus then to allow the customer to connect to us and control us. And just as a side note, we also typically do HMI touchscreens, and that's actually nothing but an HTML web page. So this is part 2 of the part 1. We talked about MODbus, TCP in general, and to expand upon that, this MODbus can be used on serial communications, it can be used on Ethernet communications. It's a protocol that can be used on various types of hardware. So one of the key features that you'll need to know is that you need a MODbus table from the manufacturer of the equipment. For example, when I need to talk to a temperature and humidity, I need to know what address to ask for the temperature on. I need to know what address to ask for the humidity on. The device responds, it gives me that information. Same thing occurs, ECU1 can talk to ECU2, ECU2 can talk to ECU1. The real key is these ECUs can be talked to by the customer. Customer needs a MODbus table where we tell him, if you want to change the set point temperature, go to this address. If you want to change the set point humidity, you go to this address. And that's how the customer can change settings, they can start and stop our units, they can look at various pressures and transducers. And the other thing that you need to know from that table then is, what are the parameters? Many of them are read-only. You can only read a temperature. An interior temperature, you can't set that temperature. Some of the parameters are read and writable. You can write to us to change for a new set point temperature that you want the ECU to regulate to. The other thing you need to know is the parameter a Boolean variable, just 1 or 0? Is it true or false? Is the parameter 8 bits or a byte? Is it 16 bits to make a word? Is it a signed number or an unsigned number? You also need to know, is there perhaps an assumed decimal point? In the MODbus world, most people don't bother with floating point numbers because you have to send a lot more information back and forth across the connection. So a lot of people dumb it down and might send 3 digits and tell you there's an assumed decimal point. So 720 might really mean 72.0 degrees. This is all in the MODbus table and is the key piece you need to use with our equipment. Here is an example of an in-house program we wrote to test the MODbus functions as we develop them in the PLCs in the ECUs. What this program is doing is connecting to one of the PLCs, and it is reading a bunch of MODbus registers. And as I mentioned earlier, with a MODbus table to define what each of these addresses is, now you have the ability to read and write different parameters. What you're seeing above here is a development of an HMI screen that the customer would use to set various modes in the ECU. And as we change these modes up here, we can see on MODbus, for example, address 3 is the mode that the ECU is in. So if I go to off, address 3 is 0. If I turn the unit to fan, address 3 is 1. If I go to auto, now it becomes 2. Now, you may ask, why do we have both? Well, this is the HMI screen that would probably be installed inside the shelter for the typical user to have access to. But if the shelter system has a main computer network running, tying all the equipment together, then they can use MODbus to also change the modes. So for example, if I set register 3 to 0, notice it became 0 and I've turned the whole system to off. If I want to turn it back on or turn it to fan, I can write a value to it. I've got fan now because I wrote that, and the ECU2 is in fan mode. Or I can change it here and it will be updated on the screen. Another example could be the whole system computer inside the shelter could be in charge of toggling the units back and forth. So if I write a 1 to address 14, I've actually changed which is the active ECU. And it's a toggle function, so if I do that twice in a row, I've now toggled back to the original ECU, which is the same thing that someone could do at the screen. So you can see MODbus is just another mechanism for communicating with the PLCs in the ECUs to control the system. If you'd like to discuss this with our team, click the contact button or give us a call. Thank you for watching this Engineers with Markers.